Hi, my name is Polly Cost, and I work for New York Early Childhood Professional Development Institute, and this is my first video on YouTube about exponents. So let's get into it. Okay, so first things first, I want you to get out a sheet of paper and one or two pencils. I want you also to get a glass of water and an eraser and maybe a calculator. Let's get started. Okay. I'm just shifting the computer so that way you can see my sheet as well as I can see the sheet as well. Okay, so let's have a look. So first things first, let's look at the word X. Can you see that? Let's see. Hope you can see that. Let's see. Exponents. Let's have a look. Can you see that? I'll move it. Alright, let's have a look now. Ooh, now it's looking good. Alright, exponents. So first things first, what we want to do is ask ourselves, what is an exponent? When you have, let's say, 7, right, to the second power, this upper right-hand corner number is called an exponent. Exponent. And this number, kind of like if this were Statue of Liberty and the torch is like the exponent, so this statue right here is called a base, and it kind of holds this exponent on the right hand, upper right hand corner, and it's always like a smaller number. So like, let me give you another one. So here 5 is the exponent, and 8 is the base. And exponents can be integer numbers, like this. It could be 9 to the 7th power. So here 7 is the exponent. Uh-oh, whoops, I'm sorry about that. 7 is the exponent, and 9 is the base. So now the question is, why do we need the exponents? Why are they important? So a lot of times when mathematicians want to write numbers as a member of their, as an expression of the factors, what they like to do is show an expression. So let's first go over how to say exponents. How do we state exponents to our friends, to our family, to our teacher, to our professor? So if I have 2 as the exponent, like this, 4 with exponent of 2, we say it like this: 4 to the second power. Okay, so if we have 5, that squared, it's 5 to the second power. Now, another word to say to the second power is squared. So we can also say, the semicolon means also. We can also say 4 squared. For this one right here, 4 squared, right? Or we can say 4 to the second power. For 5 squared, or 5 to the second power, let's just write that down. 5 squared. So 4 to the second power or 4 squared. 5 to the second power or 5 squared. Let's see. What if we had 9 to the third power? Let's look at that. Okay, so this we say 9 to the third power. So it's always to the something-th power, right? Here it's third power, right? and we say 9 cubed. So anything to the power of 3 is going to be cubed. Anything to the power of 2 will be squared. So know that they're interchangeable. Second to the second power is the same as squared. To the third power is the same as cubed. Let's try another one. How about, let me think, 8 to the third power. So that's 8 to the third power, which is the same as 8 cubed. Well, part of you might be thinking, well, Polly, can we have negative numbers as bases? Oh, yes, you can. Let's do some negatives. Negative 5 to the third power. So that's negative 5 to the third power. Or negative 5 cubed, right? What does negative 5 to cubed mean? Well, that's a good question. Whenever you look at your exponent, it tells you how many of the bases you're going to see. So right here, I spat. Oopsie, forgive me. So that says there's going to be 3 of these negative 5s. So I'm going to have 3 lines here. And what I'm going to have is 3 negative 5s. Oops. Gotta slow down and be careful. So if I have 3 negative 5s, whenever I have an exponent, it shows you how many copies of the base you see. The exponent tells you the number, 3 copies, 1, 2, 3. Now, whenever you're using exponents, they really mean multiplication, right, of itself, right? So if you're starting with number negative 5, negative 5, negative 5, what you need is something to show the multiplication. I'm going to use dots. Feel free to use, you could use parentheses. You could use asterisks. Well, you don't need parentheses then, just asterisks, right? So you can use parentheses, middle dots, right? Asterisks, right? You can also use the old-fashioned operation symbol for multiplication. And now I just want you to know, as we go into algebra, we're going to be moving away. We're going to be moving away from using this symbol, because if we had x times x, if it could get messy. Sometimes people are confused. Is that an x? Or is this an x? So confused. So what they end up doing is using these other symbols, like this, 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 or this. Now remember, if you ever have a variable that's a letter that represents a number, like this, a times b, right? The mathematicians do not always show the multiplication. So whenever you have a letter or a variable next to another letter or variable, know that there's multiplication here. So I'm just going to write multiplication occurring is happening. But it's invisible. And it's understood. Whenever you have 2 letters, 3 letters, 4 variables next to each other, and there's no space in between, it's always multiplication, and it's always happening. I hope you can see that. Let's have a look. Oops, I'm off center there. Okay, now that we know that negative 5 to the third power is negative 5 times negative 5 times negative 5, let's go ahead and find out the answer. Negative 5 times negative 5 will give you, negative times negative is a positive, because if you have you have a negative friend and another negative friend, that's a positive relationship. They can talk about negative things together. 5 times 5 is going to be 25. Now we got to go ahead and multiply that by another -5. So right here, this is one copy of -5, two copies of -5. This is the third copy of -5. So a positive times a negative will be a negative, because if you have a positive friend with a negative friend, that's a negative relationship. So I wrote negative. 25 times 5. Think of this. You have 25 cents. You have 25 cents or 5 quarters. That's $1.25 or 125 cents. So it was 125. So then the answer here, after you simplify this expression, -5 to the third power, it will be -5 times -5 is 25 times -5 will give us the solution of -125. Okay, are you ready for more? I really hope so. You're doing great. Let's try. What if I have something like this? 8. Can you see that? Let's see. There we go. 8 to the 0 power. Now remember, anything to the 0 power is going to equal 1. Okay, so if I have x, y, z to the 0 power, that's going to be what? 1. If I have -1 million to the 0 power, that's 1. Now, things change up. Whoops, what happened there? Oh, I'm sorry about that. Now, things change up if there's a negative in front. So let's go ahead and try -9 to 0 power. So we know that what 9 to 0 power, 9 to 0 power is 1. So the negative means the opposite of. So ask yourself, what is the opposite of 1? Now this 1 doesn't have any sign in front of it. So we can automatically say to ourselves, this is a positive. So what's the opposite of +1? Negative, right? So let's go ahead and try another one. Say we have 4 to the 3rd power. So that's 3 copies of 4, right? Or 4 cubed, right? So what's happening between the 4s? Multiplication, because exponents are just multiplication by itself. 4 times 4 is 16. Bring down the multiplication, bring down the 4. Now we just have to do 4 groups of 16. You're probably wondering, why didn't I do 16 groups of 4? Well, 16 groups of 4 is going to go all the way off this sheet. And we want to keep it on the sheet. So I can always choose, whenever I have multiplication, I can always choose groups. So 16 groups of 4 or 4 groups of 16. Because in multiplication, order doesn't matter. So I'm doing 16 plus 16 plus 16 plus 16. 16 plus 16 is 32. 32 plus 32, so 30 plus 30 is 60. 60, and then 2 and 2 is 4. So that's going to be 64. Okay. Alright, let's try one more, and then we'll end it there. How about 2 to the 5th power? That's 5 copies of 2. So I'm putting the base 5 times. It's almost like I'm going bramp, 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 right? So now what's happening when you do exponents? You multiply. 2 times 2 is 4. 2 times 2 is 4. Now I'm going to bring down the multiplication, bring down the multiplication, bring down this 2. 4 times 4 will give us 16 times 2. So that's 16 groups of 2. two groups of 16. Because remember, order doesn't matter in multiplication. So I'm going to do 16 plus 16. This is two groups.